Okay, so for chemical reactions, I have 5 main types of reactions. Synthesis, which is 2 things coming together to make one thing. You recognize this because you start with 2 elements and you make one compound. Really common example, Na plus Cl2 because of Hunkelbrief makes NaCl. NaCl because of hands, they each have 1. If I balance like that, that's a synthesis reaction. 2, decomposition is the exact opposite. If I have one compound like AB and I break it down into A plus B, I have 2 elements. Common example would be water broken down gives me H2 plus O2 because of Hunkelbrief again. And if I balance, I have that. Next reaction, single replacement. If I have one element and one compound, I switch one out. So I could either switch A and B or A and C, it depends. If A is positive, I have to switch it with B because they're both positive. If A is negative, I have to switch it with C because they're both negative. So if I am walking by and Usher is with his lady, I can only replace Usher's lady. I'm not going to replace Usher and hang out with his lady. That'd be silly. Common example, if I have NaBr and I put Cl2 in it, Cl2, Hunkelbrief, but it's negative, Br is the negative one, so I switch out the 2 negatives, and I make NaCl plus Br2 because of Hunkelbrief, and don't forget to balance. If I look at reaction number 4, it's really similar to single replacement. It's double replacement. I have 2 compounds, AB and CD, and I make a double rainbow. I put AB together and then CB together. The reason I write CB is I have to put the positive first and then the negative, just like when you write a letter, you write Mr. and Mrs., positive first, then negative. An example, if I have sodium sulfide and I mix it with calcium oxide, the Na and the O go together, I have to do hands to get Na2O. The S and the Ca go together, when I do hands, I get CaS, and then I would have to go balance. Last reaction is a kind of weird reaction. It's called combustion. It doesn't follow the rules like the other one. It's any carbon and hydrogen compound burned in oxygen gives you carbon dioxide and water. So for example, if I had C3H8 and put it in oxygen, you know, no matter what, always, it will make carbon dioxide and water.